Hi everyone, I am Mohit. I am studying first year BTech in SRIT College. In this video, I am discussing about interplanar spacing distance between two planes in engineering physics. Now, consider a cube edge of cube crystal BA and HKL be the Miller indices of the plane ABC. You can see in figure that ON equal to D1 be the perpendicular of the plane ABC from the origin. Let ON equal to D1. D1 is interplanar distance and alpha dash, beta dash and gamma dash be the angles between coordinate axes XYZ respectively on ON. The intercepts of the plane on three axes are OA equal to A by H, OB equal to A by K, OC equal to A by L. Here the cubic is A is same on all sides because it is a cubic crystal, so sides are same. Now consider cos alpha equal to D1 by OA, cos beta dash equal to D1 by OB, cos gamma dash equal to D1 by OC. By cosine direction rule, we know cos square alpha dash plus cos square beta dash plus cos square gamma dash is equal to 1. Now substitute the above values. In this we get d1 by OA whole square plus d1 by OB whole square plus d1 by OC whole square equal to 1. Now we know OA equal to A by H, OB equal to A by K, OC equal to A by L. Substitute this we get d1 by A by H whole square plus d1 by A by K whole square plus d1 by A by L whole square equal to 1. Now solve this, we get d1h by a whole square plus d1k by a whole square plus d1l by a whole square equal to 1. Now in above we common we get d1 by a whole square into h square plus k square plus l square equal to 1. Here we solve this, we get again d1 square equal to a square by h square plus k square plus l square. The square root we get d1 equal to a by root of h square plus k square plus l square. Now again we can consider another plane which is parallel to first plane. Let OM equal to D2 be the perpendicular of next plane PQ are parallel to the first plane ABC. The intercepts of these planes on three axes is OP equal to 2A by H, OQ equal to 2A by K, OR equal to 2A by L. Here the cube edges we can take 2A because this is the second plane. Let alpha double dash, beta double dash, gamma double dash be the angles between coordinate axes XYZ respectively. Now cos double dash equal to D2 by OP plus cos B and cos beta double dash is equal to D2 by OQ, cos gamma double dash equal to D2 by OR. Now by direction cosine rule we get cos square alpha double dash plus cos square beta double dash plus cos square gamma double dash equal to 1. Now substitute above values, we get d2 by OP whole square plus d2 by OQ whole square plus d2 by OR whole square equal to 1. Now we know OP equal to 2A by H, OQ equal to 2A by K plus and OR equal to 2A by L. We substitute these values, we get d2h by 2a whole square plus d2k by 2a whole square plus d2l by 2a whole square equal to 1. In above d2 by 2a is common, so we can take common d2 by 2a whole square into h square plus k square plus l square equal to 1. Now d2 square is equal to 4a square plus h square plus k square plus l square. Now d2 is equal to 2a by root of h square plus k square plus l square. Now finally we get the interplanar spacing distance is d equal to d2 by minus d1, d equal to d2 minus d1. Now substitute these values, we get d equal to 2a by root of h square plus k square l square minus a by root of h square plus k square plus l square. Then d is equal to a by root of h square plus k square plus L square. Now you can see some example problems based on interplanar distance. If the lattice constant of a cube crystal is 3 angstrom, find the interplanar spacing distance between 111 planes. The definition Miller indices. Here they give A equal to 3 and H equal to 1, K equal to 1, L equal to 1. Now D is equal to A by root of H square plus K square plus L square. This is the interplanar distance. Substitute these above values, we get 3 by root of 1 square plus 1 square plus 1 square equal to 3 by root 3. The solving we get D equal to root 3 angstrom. In this way we can solve the problem by using the interplanar distance. Now see some applications for this. First, crystal structures identification using X-ray diffraction to determine the type of crystal and atomic arrangement. Material characteristics such as calculating lattice parameters and detecting microstructural changes. And third point, stress and strain analysis by observing changes in D spacing to identify internal stresses or defects. Fourth point is phase identification in alloys and minerals to detect phase transformation and multiple phases in materials. Fifth point, quality control in industries like electronics, pharmaceutical and construction to ensure correct crystal and purity. This is the application for interplanar spacing distance. Thank you.